Hello everyone, very good evening. I welcome you all for the actual GATE 2022 the paper analysis of civil engineering. So as you know, today the February 12th 2022 year we had this civil engineering GATE examination in multiple sessions. So we had one exam in the morning session, another exam in the afternoon session. So one thing here I want to point out that this year if you see in GATE 2022, if you see the earlier, the other branches like computer science, electronics and triple E, electrical. In these three branches, the exam was held only in one session. Whereas if you see this civil engineering as well as mechanical, the civil and mechanical, these are going to be held in 2 sessions each. So that implies we have relatively good competition in the case of civil engineering as well as mechanical engineering among the aspirants. But you don't have to get any discouraged moment about this one. So in the today's examination, some of you might have performed very well according to your expected level, and some of you might not have performed as per your expectations. Some of you might have got very disappointment also. It happens in any examination, but whatever may be the case, whether you are satisfied or not satisfied, don't stop your preparation. Just because you have got very good marks, you are going to get good marks in the GATE exam of this. Don't stop your preparation. Why? Because I tell you, suppose you have performed very well in this GATE exam, definitely you will be aiming for the engineering services that is coming on this month, February 20th. So you have to continue preparation, whether you have performed well or not in the GATE exam. You have to continue preparation at least for this engineering service prelims exam, which is coming on 20th. Suppose you have not performed well in this GATE examination. Let us say that you have not performed well in the GATE examination. Suppose you are aiming next year. Even then, you can't stop the preparation at this stage. So what I want to say, friends, whether you have performed well or not, whatever may be your performance level, you have to continue your preparation. Moreover, I want to remind you that even though you are not interested in joining, even though you are not interested in the engineering services, suppose you want to join PSU, suppose you are getting very good marks in this, let us say, GATE examination. In every PSU, you have to again face some interview and group discussion, etc. there. So you have to continue preparation. So that's why whether you have performed well or not, you have to continue preparation without any stop there. And one more point here. So I have seen over the years of our experience here, some students after appearing this GATE examination, suppose they are not able to perform according to their expected level, they get a lot of disappointment, right? And they feel in negative manner. See, one thing what we want to tell, whatever happens, happens for your good only. Because who knows, next year if you are, suppose you are not able to perform this year as per your expert level, maybe next year you may be going to get very good rank in the GATE examination. We have seen in fact in our academy that some students who were disqualified in 1 year, when they continued the preparation, the very next year they were able to crack this GATE exam with all India single digit rank in the top 10 as well in the top 100 also. So that's why whatever happens, it happens forever good only. So don't lose hope, don't lose hope. Right? I always tell the student that a war never goes waste. So if you are prepared thoroughly for GATE examination but not able to perform in the actual examination today, means don't lose hope, right? Don't lose hope. Maybe in the next attempt when you appear any other examination or any interview, etc., this preparation will not go in vain. It will definitely come to your rescue. So with this small introduction, let us go to the discussion, otherwise the analysis of this civil engineering GATE 2022 paper. So first of all, let me tell you that all these questions that we are going to present here, they're all memory-based questions. These questions we have gathered from our students. So most of the students, they have shared these questions. Still, some students are posting these questions because we can't rely upon these questions which are posted by only 1 or 2 students. We have to compare with the questions posted by the other students as well. So after a lot of compilation, we are able to present this one. So there may be a few mistakes unknowingly here, but kindly excuse us. To the extent possible, whichever is possible with us, those questions we are trying to analyze here. And I could see still the students are posting the questions. Please keep posting these questions. And also, I request you, right, please like it, share it, and also subscribe to our YouTube channel, because we'll be coming up with many more latest updates also from our ACE Engineering Academy side. Right. So I'll be joining with my other colleague faculty members. In fact, we have what you call many colleagues of civil faculty fraternity in ACE Academy, but because of this, the COVID conditions, etc., some of my colleague faculty members are out of station, they could not make it up. So that's why with some limited number of faculty members, we are continuing this further discussion on this GATE paper. So first we'll take up the forenoon session, then we'll see the afternoon session paper. So let me join with my friends. So we have the other faculty members, we 5 members are going to analyze most of the subjects here. Coming to the what you call the breakup of these questions, etc., let me tell from my side a few subjects. As usual, like every year, this year also, the geotechnical engineering proved to be the main subject, which was it was given what you call around 10 questions. It means very good weightage relatively. And again, after geotechnical engineering, the next highest weightage was given for the environmental engineering. And if you see some subjects, as usual, for example, you see steel structures. Every year we have only 1 or 2 questions. So this year also only 1 question that is available so far with us. I think that may be correct also. Only 1 question was given from the steel structures. And regarding this project management, as usual, see, every year we have only one mark or less 3 marks totally. So here we have this year one question available with us. So that's what the subjects what I told. Coming to this most important subjects of geotechnical engineering and environment, which are given very good weightage. So from the questions that are available with us, so what we understand is they are relatively easy. They are not something from the what you call remote or some untapped areas. Especially I'm talking about this the morning session GATE paper. Most of the questions, not most of the questions, almost all the 10 questions of the geotechnical engineering, they are from the what you call the normal standard areas only. Any student who prepares for the GATE examination, they have some idea which chapters they have to focus like this, especially the geotechnical subject. So most of these 10 out of the 10 questions, almost all the 10 questions are from this common known areas only. And moreover, all these questions are relatively easy. Some of them are just directly formula based questions. I think only 1 or 2 have some what you call conceptual questions. And I heard that this year there were a few MSQs also given there. But if you see the previous last year GATE civil engineering paper, there was hardly any MSQ. But this year there are a few questions given of MSQ type also. That's what from these subjects. Let me have the opinions of my colleague faculty members. So they will also share this what you call some analysis of these subjects. Then we go and quickly present solutions on this smart board one by one each subject. So I request Kesh Reddy sir to say something about this some subjects as well as his opinion also on this.
Thank you, sir. Coming to the structural subjects, analysis and design subjects. This year the questions are very easy, and almost the calculation part also you can do it without calculator. Even though they are supplying you online calculator, you can do it without calculator. In my opinion, the questions are very simple, straightforward, with the average level preparation, without confusion in the exam hall. You can do much better compared to the previous years. These questions are this paper, I am talking about the morning session paper, is very easy. And coming to the strength of material, I have with us only one question. there may be other questions also. That question is very easy. Easy question coming from thin cylinders. With the data available with us, I am telling you, I have only one question with me. Coming to the RCC part, we have 2 marks question, numerical answer question, and that is vertical stirrup spacing question. Direct, if you remember the formula and if you remember simple specifications, you can hit the target. And another is a theory 1 mark question. They are asking about the modular ratio in elastic theory, working stress approach. So 3 marks came from RCC. As per the questions available with us, only 3 marks. 2 marks, 1 numerical answer question and 1 multiple choice question of 1 mark. Coming to the structural analysis also very simple questions, direct straightforward questions came. And 1 question from the moment distribution, a 2 marks question. You can do it in 1 minute of time, hardly 1 minute of time. And another is ILD question also with simple concept you can do it. There is also multiple select question. Coming to 2 marks question, this is also 2 marks question. Another 2 marks question on the frame. They asked the member force in a frame, and by method of joints, it is very difficult to
that we discuss
take care.
on the board, just to cover that.
Yes.
Number
So
of
totally with me, I have 2 marks questions and 1 mark question. So totally 5 marks came from structural analysis. The details will discuss it on board. So I'll pass it to my fellow colleague, Abdul Bari.
I'll be dealing with the subject of mechanics and fluid mechanics. As far as mechanics is concerned, we have one question only, and that happens to be a multiple option questions. And that question has come from friction, a very interesting question. We'll discuss it as we move further. In fluid mechanics, as of now, I'm only having 2 questions, and both the questions happen to be very simple questions. One has come from the concept of dimension analysis, very fundamental question on various numbers, and the other is a question on branching of pipes. Okay, it's a case of parallel connections. Both the questions happen to be very simple, very fundamental questions. So I realize that all the questions, whatever we have discussed, we are going to discuss, more probably they'll be coming from the concepts which are not that much difficult to identify in examination. Okay. Let us move further. We'll discuss about open channel flow by Narayana sir.
Good evening, friends. As our colleagues are telling, I agree with that opinion regarding my subjects. Irrigation engineering, they have given one mark question and 1 2 marks question, total 3 marks. They are very easy. And in open channel flow also they have given 1 mark question, 1 2 marks question, total 3 marks. Open channel flow question is given. Both are coming from varied flow only. One is channel transition and the other one is gradually varied flow. So very easily we can answer, easy to moderate only, not even a single question is a tough question, and we expect good ranks from these standards of paper. Papers are of moderate standard. I request Pradeep sir.
So very good evening to all my dear students and good evening to my fellow faculty sirs. So I'll be talking about 2 subjects here, that is surveying. After that we'll talk about transportation. Okay. So surveying, as usual, expected weightage only came. So we were expecting 4 to 6 marks weightage. So from surveying foundation session, we are having around 3 questions. So that will put it roughly into the bracket of 4 to 6 marks. Okay. So there are 3 questions here, out of which one of all the 3 are actually numerical answer type questions. We believe so. Okay. And expected areas was only asked. They have asked 1 question from aerial photogrammetry as expected, and 1 question they have asked from compass surveying. That was from the basics only. They have asked about the bearings. Okay. So interesting, they have asked about azimuth. Okay, we'll talk about what azimuth is, right? And from chain surveying, they have asked a question regarding corrections. Okay. Now corrections have not really asked so much in GATE examination, but the interesting part is the same question that we have done in our APL, that is ACE Premier League, the exact same question they have asked in GATE 22 forenoon session. Okay, so I think a good number of students have watched those videos, so I think you'll be very happy to see that the same question has repeated. Okay, so that's just regarding our surveying topic. And coming to transportation, as you know, it is one of the major subjects, highest weightage is there for transportation. And overall what we can say is transportation and surveying and geotech and environmental, they were I think a full gift to you, right? So GATE have considered how difficult the last 2 years were for you, and they have considered as a gift and given to you. I think I think 80 to 90% students will be very happy. Okay, so coming to transportation, we are having 5 questions with us, and no theoretical questions came as expected, and numerical only have come. Okay, simple analysis only there. None of the questions are very difficult. Okay, we'll discuss about them in detail. Direct formula substitution is coming only, right? And you'll be happy to see what our discussion will be looking like. Okay, so we can expect some higher marks here. GATE first ranker can get top ranks here, top marks here. We'll see that. Cutoff is also going to high. So we'll talk about that. I'll hand it over to AK sir to talk about the expected cutoffs and all.
Okay. See, all my colleague faculty members, they have discussed in detail about the chapters where the questions were given in this GATE 2022 forenoon session. But I just said the only total numbers. So as a continuation of formality, just let me say that the chapters where the question was given from this GT subject. So what I could see is one matching question was given. Very simple question like normally consolidated clay, Q clay like this. That is, I can say that is from the partly from the shear strength chapter and partly from the basics only. Very simple matching question. And another question was given from the properties of the soil, just a formula based only. Very easily you can work out, without calculator also you can solve this question. And one question was from the pile foundation, that is also a basic problem. Without any difficulty you can solve this question. And another question is from the stress distribution chapter and the Bose-Niska theory it was given, just a direct substitution in the formula only. And one question from the permeability chapter. And I think in fact I should say one question from the permeability chapter, one question is from the permeability as well as the capillarity phenomena, and one question from the consolidation chapter. Every year consolidation chapter is one chapter where questions are asked, like consolidation chapter, pile foundation chapter, they're all properties of soil, really routinely asked every year. As usual, this year also it happened. And I think a couple of questions were from this earth pressure, lateral earth pressure chapter. And that's what from this soil mechanics. And regarding the steel structures, there was one question given from the welding chapter. Just an angle was attached to the gusset plate. You were asked to calculate those length of the what you call weld length. That was the question. Is also I think is a standard routinely asked question only. And one question from the project management. It was given on the CPM. You were given some activities. You are asked to find the critical path. Very simple question. It's a routinely asked question. You will take a GATE exam or engineering service, any exam you take is routinely asked question. You are given some few activities. You have to draw the what you call the network for this. You have to find the critical path for this. And regarding environmental engineering, this is also given good weightage, but some of the questions are still in the process of receiving. Somehow you couldn't get all the questions of environmental engineering, but I could see one question given from the sewage analysis regarding that initial organic matter calculation L, and then one question that is calculation of the hardness problem. In fact, if you see the history of the GATE exam, every year almost, if not every year, at least alternate year, you do find one question from the hardness calculation. This year also it was given from the hardness calculation. And there are some what you call a few theoretical questions also there. So rest of the questions are not available with us. Kindly excuse us. I think still some of the students are sharing those questions. I request the students please post those questions which are available with us. Right. So with this, I could hear from my other colleagues also what they were saying was related. There were some easy questions from their subjects. So with this and over with our past experience, I could say that students definitely will get very good marks. But one thing, where the paper is easy or tough or moderate is a relative examination. But what I could understand from the discussion among my colleagues is those who have made the regular normal preparation, not extraordinary preparation, just ordinary preparation also, they will be definitely able to score good marks. Because paper is somewhat easy and routinely asked questions. I think the cutoff will be, in my view, it can go beyond 30 plus will be the cutoff. That's what my expectation in the morning session. And if you see the All India first ranker, if you see last year the All India first ranker, I think it was something 95 plus, if I am correct. And this year, because the paper is somewhat easy, I think the All India first ranker may get somewhat in the same range, around 95. That's what my feeling. But let us seek the what you call the opinion of my colleague faculty members also. What Keshav Reddy, what do you say about this probable cutoff and then the All India first ranker likely marks? In your
Definitely,
opinion?
In my opinion also around 95.
Around 95.
Because there will be silly mistakes.
Yes.
So beyond 95 is very difficult. But few people it is possible, but 95 may be the probable cutoff.
Yes, right. What do you say, Bari, about your, what is your take on this one?
We can only say right now, based on the technical part of the paper, there is still a good amount of contribution from non-technical part. But more or less non-technical part, if a person is good at technical, and we expect him to be good at mathematics and aptitude as well. So you can expect the cutoff to be beyond 30 only, because the kind of questions I'm seeing, these are the questions for which you are not supposed to go beyond your range to prepare. Within your limits itself, you can get these questions very easily. You don't have to extraordinarily work hard for this.
Yeah, that's what,
Right.
with ordinary preparation,
Yeah,
you don't have to make extraordinary preparation.
Exactly.
With the routine preparation.
So if the non-technical part also is in the same range, then you can very well expect around 95 for the All India rank 1.
Yes, that is one point. Actually, we didn't have the feedback of that what you call general
Non-technical,
aptitude as well as that mathematics part.
yes.
But I have made inquiry with our colleague faculty members. They were saying that the questions are somewhat easy to moderate only. Easy to moderate. So with that perspective, we can say that, right?
Yes.
But one thing here, the exact cutoff, the All India first ranker, exact marks, nobody can predict exactly. Right?
Yes, sir.
It's only your individual perception based on the feedback of based on the memory-based questions given by our students. It may vary, obviously. That's what you say. See, All India first rank at 95 is not exact 95.
Yes.
There can be plus or minus 2 also, or plus or minus 3 also. Around 95, that's what you want to say.
Normalization will also come when second paper is out.
Yes.
Normalization will also come into picture. So we'll have to see afternoon session also.
Yes. Because if you discuss the paper 2 also, then based on normalization marks, one can say that what will be that is also true.
Exactly,
because
right.
we should not come to the immediate conclusion just based on this paper 1 analysis alone.
Yes.
We have to take into account the paper 2 also. That part we have not considered. This is our analysis based on the paper 1 only, morning session paper.
True.
So if you see the paper 2 also, it's a level of the paper, right? There again, if you see the standard and all, then you can come to some approximate conclusion there. Okay. Anything, sir, you want to add from your side? Right? One more thing, Pradeep, and you have to tell. Compared to the previous papers,
Yes, sir.
do you find anything special in this GATE 2022 from your side?
Sir, they have not really gone into the untapped areas. That they have not done. So actually last year maybe slightly they have gone into that. But this year this just came from direct areas only. So what everybody will focus, just our classroom practice questions, that will be more than enough.
So
Basics.
there are no untapped areas.
No untapped areas.
From your transportation as well as
Yes,
surveying.
surveying, yes.
Yes, I do agree with the what you call geotechnical engineering also. Even if you say pattern CPM also same thing. Even the steel also same thing. So what about your subjects, Keshav Reddy?
Same thing, sir.
So no untapped area.
Questions are straightforward and very simple. Even though for 2 marks question 3.6 minutes of time is available, within 0.6 minutes of time most of the people can solve. And I hope the topper might have completed the total paper in 2 hours.
Yes,
2
sir.
hours.
Yes, possible.
This is encouraging point for the aspirants who are watching this live session.
Actually speaking, in my point of view, last 20-year papers, if you see, this may be the
Easiest.
gift.
Yes.
Yeah,
Previous year questions also, if they solve,
Yeah.
they'll get good score from this.
Even if you solve previous year papers, you can hit the target.
Yes.
That too to the maximum.
Yeah, subject. See, I just want to remind that this is only with regard to the morning session paper. Morning session paper.
Even
morning
afternoon session also,
Same
almost
response.
as we are receiving the questions,
Yes,
those
yes,
are
yes.
also of the
So
same
that's why
kind.
we are
Same
unable
one,
to
yes.
comment fully on this afternoon session because the questions are still in the receiving stage only.
Yes.
At all, of course, we have got some questions. So hopefully, after this paper one analysis, we will come up with the paper two analysis. Then we make the final conclusion in such case. And then, right, anything that you want to add?
We can go further with the.
So
With the questions.
yeah. So I once again tell this all the aspirants as well as students who have already given this GATE exam that if your performance is not up to your expected level, don't get discouraged. Don't get discouraged, right? Keep trying because we have seen students they keep on trying 2 times, 3 times also sometimes. That is the reason that why the competition level has gone so high, especially in the civil and mechanical papers in the recent years. So that's why, in case the performance not up to your expectation, nothing to get discouraged here. Keep trying, keep trying. That's what I want to say. So with this, we want to present quickly the solutions of those questions which are available with us. I think we have most of the questions. We will be presenting that solutions. But one thing. Again, I tell you that these solutions are based on that memory-based questions. There may be some small mistakes, and moreover, all the questions also not available. Once I think within a couple of days, the IIT is going to keep in their website the actual GATE paper. It's going to happen in the next week only. The moment the IIT keeps the actual question paper in the website, very next moment we are going to give the detailed solutions of each and every subject with all our elaborate comments on that one. So that's why here we just want to give what you call quickly some brief idea only how to get the solution.
Yes.
Geotechnical engineering subject. Let me begin with this question. It was a matching question. You can see that very simple question without any difficulty. You can answer this one. Normally consolidated clay. In the case of NCC, the OCR will be equal to 1. And quick clay, a clay is said to be quick when the sensitivity is more than 16. So I always say students in the class also that how to remember the sensitivity 16 for the quick clay. 16, the numerical, sweet 16, always I say, you can see our class notes, etc. You find this very routinely asked objective question. So quick clay, the sensitivity is more than 16. And then sand in the critical state. In the case of critical state, the soil will behave like a fluid. In the case of fluid state, the friction angle will be 0. So this is the matching point. And the clay of high plasticity. You can say high plastic clay, otherwise high compressible clay. That happen in the case of liquid limit high values. So liquid limit more than 50, that is the corresponding matching for this one. That is how you can match this question. This is one of the simple question. The next question is on the properties of soil. You can see that what you call volume 1 is given, that is 10,000 meter cube, and void ratio is given 1, and the soil is compressed to, so volume is compressed to 7,500 meter cube, and you are asked to find the what you call void ratio. This is also very simple, routinely asked objective question. I always give in the class also one simple relation that volume is proportional to 1 plus C. So accordingly, we can write this equation V2 by V1 is equal to 1 plus E2 by 1 plus E1. What is E1, E2? You can see in this, right? So from this, upon solving this question, you will get the void ratio in the compressed state as 0.5. And then this is a question on the concrete pile, but the shape is given as a square shape. Length is given. And here only one point where you are likely to mistake is you are given here what is called unconfined compressive strength. It is not what you call cohesion. This point you have to keep. Generally students do mistake here only. When you are given compressive strength, you know how to take the what you call unconfined cohesion value. Cu is equal to unconfined compressive strength by 2. So that comes to be what you call 50 kilopascals. That is the cohesion that you have to take. This is one point you have to take. Length is given, NC value given, alpha is given, and moreover you are given what you call here the ultimate capacity of the pile, 632 kilonewtons. You are asked to find what will be the side of the square shape. We have here a standard routinely used equation for the calculation of the strength of the pile, that is ultimate capacity of the pile is equal to the area at the base area at the base means that is B squared because of square shape, and the cohesion at the base, that is CUB, and then NC. This gives the base resistance. Regarding the skin resistance here, surface area, because it is a square shape of pile, the perimeter comes to 4 times of each side, and then the length, the alpha, as well as the Cu value. Here everything is available except this B. B is unknown here. So the Q value what you have to use is 632 kilonewtons. 632 kilonewtons. Rest of parameters are very, they are available there. So from this you are going to get what you call a quadratic equation for the B. Upon solving this quadratic simple equation, you are going to get the width of the pile foundation as 0.4 meters. So I am not going to the detailed calculation, etc. It is all known to us, and because of time constraints, I am trying to compress this solution part there. The next is, this is on the stress distribution chapter. You have to mainly understand here what is being asked here actually. So this is something like this. You are given that on a ground surface we have a constant load, that is a Q. You are given directly below the load the 2 points. This is 0.1 and this is 0.2. Here you have the 2 stresses. Let us say this is a sigma, what is said there, point P and Q. This is point P and this is point Q. This I can say sigma ZP and this is sigma ZQ. Because the 2 points are directly below the load, you can use this equation as per the Boussinesq theory, that is sigma Z is equal to Q by Z squared into 3 upon 2 pi. So from this you can work out that sigma Z is inversely proportional to Z squared. So upon substitution here, the sigma Z value at point P, sigma Z value at point Q is equal to the Z value of the point P and the Z value at the point Q whole squared. So when you solve this, the equation sigma Z at the point P and sigma Z at the point Q, that works out to be 4. Sorry, here I have taken, it is inversely proportional. I have to write this one. This is a sigma Z Q and this is sigma Z P. Kindly excuse me, this is inversely proportional. So this is nothing but this is a 2 by 1 whole squared. That comes to be what you call 4. This is the solution for this. Is routinely asked the question only. Next is here 4 different soils are given. As per the soil classification system, the names are given, notations are given. This is somewhat a tricky question. You are asked to arrange these soils in the decreasing order of hydraulic conductivity, nothing but permeability. And these are options given, but here I have one doubt here. Because it is a memory based question, I think there must be somewhere mistake here. Why? Because let me tell you the reason for this. You are asked to arrange the soils in the decreasing order of hydraulic conductivity. Here if you look at the 4 soils, highly compressible clay, that is a low compressible silt, poorly graded sand, well graded sand. You all know that sands are highly permeable. But there are 2 types of sands there. One is a poorly, other one is well graded soil, well graded sand. Here you have to come to a conclusion that between the poorly graded and well graded sand, which is more permeable here. Let me tell you. For that you have to understand the meaning of this well graded sand. A sand is called well graded when it has got all the gradations, I mean all the different sizes, and you have a good gradation, you have a good interlocking. So in this case, we have coarse particles, we have medium size particles, we have fine particles. The voids of coarse particles are occupied by the medium sized particles. The voids in the medium sized particles are occupied by the fine particle. That's why there is a good packing here. Because there is a very good packing, water cannot flow so easily compared to what you call poorly graded sand here. Why it is called poorly graded soil? Because there are all the soils are not available there. So there may be some size of particle that are missing, right? There may be some gap there, maybe some uniform sizes are also there. That's why this is called poorly graded soil. Because this is a poorly graded soil, there is no proper interlocking among the particles. That's why the poorly graded sand will have relatively more permeability compared to what you call well graded sand. Normally students will do mistake here. This is the actual answer. A poorly graded sand will have more permeability than the well graded sand. Here you have good interlocking, so water cannot flow easily. Here there is no good interlocking, that's why water can flow easily. This is a simple common sense that you can apply. And after that, between the silt and the clay, silt is more permeable. So silt comes, and clay is least permeable. So this is CH. This is the actual answer. But when you look at the options available there, it is not available. So I believe that there may be some mistake in the what you call options given by our students. So this question we have to actually wait for the actual paper. But this is the actual answer it is supposed to be. You can see here SP is there, SW is there, but this is not correct. It should be ML. So the actual answer is going to be poorly graded sand more than SW, more than ML, more than CH. So none of the options matching here. This is the actual answer that is supposed to be. Right? This is one question you need to take. Nothing is matching here. And then this is another tricky question. It's not that much a straightforward question. You need to apply your mind here. You can see here the psi represents the soil suction head, and K is the hydraulic content, nothing but permeability. Moisture content theta. Normally moisture means we use the W notation, small w, but it's not W, it is given something theta. This is the what you call volumetric based moisture content. What is the question here? Which of the following statement is true? If the moisture content increases, so that relations we don't study normally, but you can use common sense here. We can use some common sense. Actually, if you see literature, so we come across some graphs like this. We come across certain graphs like this. If you plot the suction head here, and if you plot the permeability coefficient here, and with this theta along the abscissa, as the theta increases, the permeability coefficient increases. As the theta increases, the suction head is going to decrease. That's what actual the experiment results also available. But this same concept you can also obtain based on some simple concept. Simple common sense you can use there. See, whenever the water content increases, once the voids are occupied by the water, so the suction amount is going to get reduced there. That's why as the water increases, the suction head is going to decrease. This one. So whenever the water is occupying the void spaces, the saturation levels are going to increase there. As a result, the permeability is going to increase. So permeability is going to increase. So as the theta increases, so suction head decreases, but permeability increases. So this is the correct answer. And then this is the something so lengthy the question looks there, but this basically is not a raft foundation problem. This is basically a consolidation problem. Consolidation problem. I think if I go on presenting all the detailed solution may take some time, but one concept I can tell you here. You know this equation that is TB is equal to CBT upon D squared. Here you can see the 2 degrees of consolidation, that is a 50 and a 25, both are less than 50. So in the place of TB I can use this one, pi by 4 U squared is equal to CBT upon D squared. Because both are same soils here, the soil sample as well as the actual soil present in the field. So from this I can say that the time of consolidation is directly proportional to U squared and then drainage path square. This is the equation what you can make use there. If you read the entire question, it may get confused here. It's not such a difficult question as such. This is a simple equation what you can use. So from this you can frame this equation, that is T2 by T1 is equal to U2 by U1 whole squared, and then D2 by D1 whole squared. You know, this kind of questions we solve many problems in the classroom. So there are 2 cases, 1 and 2. 1 you can take as the laboratory sample, the 2 you can take as the field clay. So when you substitute the data here, you get the T2, the time for the field consolidation. I think the data is available with me. it comes to be something around 1736 days you are going to get. Actually, I have solved the question. I remember it may be 1736 days there. And then you can see there are two stresses given, vertical stress and then it's not a sigma n. I think it's not correct feedback given by our students. It's not normal, it is nothing but this is a horizontal stress, sigma dash h. The question is, which one of the following conditions must be satisfied for a solvent to reach the failure under the Rankine's passive state? You know, Rankine's passive state means the wall moves towards the backfill. It happens when the sigma h is more than the sigma v. So, the correct answer is going to be the sigma h dash is more than the sigma v dash. Because sigma h is more, then only the wall will move towards the backfill. So, this is the correct answer. Nothing but this one only. It's not a sigma dash n, this is sigma dash h. So, sigma vertical stress is less than horizontal stress. Otherwise, you can say this one. And this is another question where the students are going to get likely confused. Likely confused here. You have to be very careful regarding the terminology what is used there. If you see here, Rankine's theory of earth pressure, the inclination of the failure plane 45 plus 5 by 2. You all know that failure plane always makes an angle of 45 plus 5 by 2, always makes an angle of 40 plus 5 by 2 with respect to major principal plane. We all know that major principal plane is parallel to minor principal stress, or you can say minor principal stress, whether it is the active state or passive state. Failure plane always makes 45 plus 5 with respect to major principal plane, otherwise we can say minor principal stress. That is what the meaning here. So, therefore, in both the active as well as passive, this is true. Don't get confused here, this is not what you call the horizontal plane. The statement is very clear here with respect to minor principal stress, nothing but major principal plane only. So, that is why A is the correct answer here. Yeah, this is the, I think, last question. This also a question that is available in our material also, you can see this comes in the soil exploration chapter regarding the static and penetration. This equation also I have given in our material. You can see that friction ratio Fr is equal to Qs upon Qc. This is nothing but a side screen friction, this is nothing but tip resistance, it is called friction ratio, a very simple equation. It is there in the soil exploration chapter. Here friction ratio is given as 1%. 1% means I can use 0.01. You are asked to find Qs and the Qc is given as 1000 kilopascals. So, upon solving the skin friction comes to be, side skin friction comes to be 10 kilopascals. 10 kilopascals is the answer for this NET type question. Yeah, that is what from the geotechnical. So, we have come across 10 questions. You have come across 10 questions.
Yes, students, this is question from strength of material. Very simple question. What they have given is hoop stress they have given, and they are asking you to calculate the maximum shear stress. Hoop stress is 30 Newton per mm square, and tau max is nothing but in 3D stress system. So, thin cylinder, they are asking you stress at this point. A simple question, you can answer within 10 seconds maximum. So, this is sigma h by 2. Because the third directional sigma r radial stress is 0. So, sigma h by 2, it is nothing but 30 by 2, nothing but 15 megapascal or Newton per mm square. So, this is the question we have with us from strength of material. Now, coming to the question on RCC. This is regarding the shear reinforcement. They have given the cross-sectional dimensions of the beam. Width is 300 mm, effective depth directly given 580 mm, and it is made of M30 grade concrete, and M30 is extra data, not required for us. Even it has 1% of longitudinal tension reinforcement, is also extra data, and they are using main steel as Fe415. This is also extra data for us. The design shear strength of the beam is 0.66 Newton per mm square. This is tau c given directly. As tau c is directly given, there is no need of the percentage of tension steel and grade of the concrete and all. The beam has to resist a factorial shear force of 400 kilonewton. So the ultimate shear force is given directly. The spacing of two-legged 10 mm vertical stirrups, they are asking you. The grade of the vertical stirrup is Fe415 and rounded to the nearest integer. If you want to calculate the design shear, VUS, design shear taken by the vertical stirrups is nothing but VU minus tau CBD. This you know. And VU is 400 kilonewton, convert into Newton, minus tau C is 0.66, width is given as 300, effective depth is 580. Calculate this VUS, design shear force of the vertical,
101.
yes, 325.16. This is directly Newton. Now coming to the spacing of vertical stirrups is given by the VUS, nothing but 0.87 Fy ASV, area of vertical stirrups, D by the spacing SV. If you substitute VUS as 325.16, Fy is grade of the vertical stirrup steel is 415 megapascal. ASV is the two-legged vertical stirrups are there, 10 mm dia. So ASV can be two-legged vertical stirrups pi by 4 into 10 square. This is the area of the vertical stirrup reinforcement. D is the effective depth. You can substitute the value, and if you calculate SV, SV becomes 101.11 mm, and as per this specification, SV should not be more than 0.75 D and it should not be more than 300 mm. Among the three, the least value you need to consider, least, and they are asking you to round it off to nearest integer. So 101.11 round it to 101. So answer is 101 mm rounded to nearest integer. This is question of RCC. Next, another question is there from RCC. In the context of elastic theory, nothing but working stress method, modular ratio they are asking. Modular ratio is nothing but Young's modulus of strong material, here it is steel, and Young's modulus of weak material, here it is concrete. Young's modulus of reinforcement by Young's modulus of concrete is modular ratio. If you look at the options, the option which is suitable for the current question is Young's modulus of elasticity of reinforcement, nothing but steel material, to the Young's modulus of elasticity of concrete. So option is B. These are the two questions from RCC. Coming to the question of structural analysis, simplest question. A frame is given like this, connecting three members together, and a moment is applied M here. The vertical leg length is 5 meter, and coming to this inclined leg, this is 3 meter and this is 4 meter. So this is again 5 meter. This is actually 4 meter here, 4 meter here. So this is also 5 meter. If you are applying the moment of M, as it is symmetrical and supports are also the same everywhere, the moment taken by each member is total moment is M by 3. M by 3 is coming up here. The moment transferred to the far end is half of that M by 3, nothing but M by 6. So moment coming at the point H, not only point H, at K, G is nothing but M by 6. They have given The moment at H is 10 kilonewton meter. What is the value of M? So M is equal to 10 into 6. Nothing but 60 kilonewton meter. So straightforward question, there is no need of EI value, there is no need of other things, a straightforward question. You can solve it less than 1 minute of time, even though seems to be a bigger question. Now coming to this ILD question, the beam PQ is given as shown in figure. A truck is moving on the girder, 100 kilonewton front axle, 200 kilonewton as the rear axle. Moves from left to right. This is the direction of movement. And they are asking you the maximum bending moment at point R. If you take ILD for maximum bending moment at point R, this is a triangle as you know, and the highest ordinate is nothing but AB by L. A is 1 meter, B is 4 meter, total length is 5. Nothing but 4 by 5. So this is the highest ordinate. The wheel loads are moving from left to right, so the front axle is 100. Rear axle will come here exactly at this point to get the maximum bending moment. Then the front axle will go forward. This is 100 kilonewton. The distance between the two axles are also given, that is 3 meter directly. So this is 3 meter. Then total is 4 meter, means this is 1 meter. So the ordinate corresponding to here from similar triangles, once this is 4 by 5, this is 1 by 5. Now the maximum bending moment they are asking you is nothing but the 200 kilonewton into 4 by 5. Next is the 100 into 1 by 5. So the answer is 180 kilonewton meter. 180 in the units of kilonewton meter. This is also a very simple question, easy question. Coming to this frame, truss question, the values are given. There is a load of 70 kilonewton is given. A value is given as 2 meter, B value is given as 3 meter. What is the member force in EF? EF is this vertical member. For that, we need to calculate support reactions, either support reactions of J or support reactions of A, you can calculate. So, for I'll try to calculate the vertical and horizontal reaction at A. This is HA and VA. You can use the equilibrium equations. This is vertical reaction at J. So if you use vertical forces equal to 0, VA plus VJ is equal to P, nothing but 70 kilonewton, which is given to us. That is one equation. To get the horizontal reaction, what do you need to do is, I'll take a section here. X1, X1, and I'll take the left of the section. This part only I'll take and try to take the moment about this point, moment about E, because this member force and this member force are passing through the point E. If you take moment about the point E, the force in this DE member, force in this inclined member will get nullified. You get HA in terms of VA. So if you take moment about E, HA is creating anti-clockwise moment, VA is creating the clockwise moment. So the equation is VA into 2A. 2A, A is nothing but 2. So 4 is equal to HA into again 2A. 2A is nothing but 4. Now you can calculate the vertical reaction. Vertical reaction at A. Substitute the value of vertical reaction. In nothing but so substitute VA is after calculation VA becomes 40, HA becomes 40. Now I want the member force here. Take a section like this, an inclined cut, you take it. So this is x1 and x1, I'll take it. Now the member forces, the members which are cutting here are, this member is getting cut, this member is getting cut. I am taking the member forces away from the joint, and you take left part of the section and take vertical forces equal to 0. Vertical force is equal to 0. I will take the force in the member is F of EF. So if you take vertical forces equal to 0, 70 is acting down, and this is also I am taking down F of EF, and this is vertical force at A is 40. So if you simplify, the force in member EF will be, this goes on to the other side, so this is 30. This is the force in the member. Okay? Yes. So these are the questions which are from the structures. So
Good evening. Let us start with the subject of fluid mechanics. As of now, we are only having 2 questions in this topic of FM1, which is fluid mechanics excluding open channel flow. One question is for 1 mark, which is a kind of match the following kind of question. The other is a numerical answer type question. Let us look at this question. It won't take more than half a minute to solve this. The question over here is regarding matching between the kind of force the type of force and the type of dimensionless number involved. Viscosity along with inertia force is going to give you Reynolds number, so A would go with 2. Pressure along with inertia force would give you Euler's number, so therefore B would go with 4. Gravity force, the entire subject of open channel flow depends on this thing, where you are having Froude number important, so C should go with 1. Compressibility or elastic forces along with inertia force are going to give you Mach number, so D is supposed to go for 3. So the answer over here is supposed to be, the code correct over here is A2, B4, C1, D3. I hope all of you could get this question very easily. Let us take another question, which is a very simple one. Look over here. The question says two reservoirs are connected by 2 branched pipes running parallel to each other. The pipes are equal in length, so L1 and L2 both of them are same. The diameters of pipes are 20 centimeter and 10 centimeter, so they are having different diameters. The difference in reservoir level is given as 5 meter, so basically the net head loss you are having in the entire system is given to you as 5 meter. Further, the question says, for the same friction factor being same, calculate the ratio of discharge in the larger pipe to the smaller pipe. Okay. Now since we are having parallel connection, we know that for parallel connection the head loss in both the pipes is supposed to remain same, because they are working within the same limits, right? So I can say head loss in bigger pipe is supposed to be equal to head loss in smaller pipe. Bigger as in diameter bigger, smaller as in diameter smaller. So if you look at this formula, I can write this as 1 by 12.1 FLQ bigger square by D bigger power 5 has to be equal to 1 by 12.1 FLQ smaller square by D smaller power 5. Now if you observe 1 by 12.1 FL, 1 by 12.1 FL happens to be same in both the cases, because he has mentioned lengths are same and the friction factor also happens to be same. He is asking you the ratio of discharge in larger to smaller, so that means That means we are interested in finding out Q bigger upon Q smaller. If you see, Q bigger upon Q smaller would be equal to D bigger by D smaller whole power 5 by 2. Diameter of bigger pipe upon diameter of smaller pipe whole power 5 by 2. Now if you look at the diameter ratio, it is 20 to 10, that is 2. So 2 power 5 by 2. If you check this value, 2 power 5 by 2 or 2 power 2.5, it would come out to be 5.657. The range I am expecting would be around 5.5 to 5.8 would be acceptable range over here. 5.5 to 5.8 would be an acceptable range. And this question, even though it is asked for 2 marks, it won't take more than 2 minutes for you to solve. It is based on the fundamental concept that parallel pipes would have same head loss. Moving further, I'll take one question from the topic of mechanics. This was a very good question. This is not a simple one. It was slightly tricky question. One reason why it could become tricky is it is first of all a multiple option based question. Okay? If you partially get the answer correct, still you are not perfectly correct. That is one problem with these kind of questions. You have to be perfect in these kind of questions so as to get the marks. Right? If you observe over here, the question is saying a horizontal force P kilonewton is applied to a homogeneous body of weight 25 kilonewton shown. This is not a particle for you, it is a rigid body for you because dimensioning is given. I have mentioned this multiple times that whenever dimensioning is done, you are supposed to treat the body as a rigid body regardless of its weight. Even it is having very less weight, still you are supposed to treat it as a rigid body. So over here 25 kilonewton body is given to you. The coefficient of friction between the body and the floor is 0.3. He has not mentioned what coefficient of friction it is, whether static or dynamic. So we would consider both static and dynamic to be same as 0.3 over here. Further he is saying which of the following statements is or are correct. Chaliye, concentrate on this thing. Now options, if you see, there are 4 options saying the motion of the body will occur only by sliding. No motion would occur for P less than or equal to 6 kilonewton. The motion of the body will occur by overturning. He could also use the word toppling over here. Overturning, turning about, toppling, all are same things. Further he is saying sliding of the body never occurs. What is the meaning of this statement first of all? Sliding of the body never occurs. If the body is experiencing only toppling, you are not going to have sliding taking place. How do you approach this question? To approach this question, you are supposed to consider all the concepts of friction at the same time. If you remember, for a body to impede sliding, it is supposed to cross the threshold limit of limiting static friction. Okay. So let us see how much would be the limiting static friction over here. Fs would be equal to mu s times n. Normal force would be equal to how much? I am expecting, since it is a memory based question, so I am expecting the surface below was a horizontal surface on which we are having this body. So the normal force would be equal to the weight itself. So therefore I could say it is equal to 0.3 times 25, which would be equal to 3 times 25, 75, so 7.5 kilonewton. So if I apply a force P over here of 7.5 kilonewton, the body is impending to slide. I don't say slide, impending to slide or at the verge of sliding. Okay. Anything beyond this, the body is in motion. Fine. Furthermore, since it is a rigid body, there is a good chance of this body toppling also. And when it is toppling, think logically, when it is toppling, it is supposed to topple about which point? Let us consider 2 points over here, point A and point B. If you push something, the 4th point is the point about which toppling would impede. So it is toppling about point A. That means the normal would concentrate completely on point A. So if I draw my free body diagram, now you have to be careful regarding free body diagram because dimensioning is done. So I am having normal over here. Let me change the ink. Normal over here. When you apply a force P, let us say W over here. W and normal are going to create some kind of a couple. That couple is what kind of couple? A clockwise couple. Friction along with P would create an anti-clockwise couple. At the point of impending toppling, these two couples are supposed to be equal and opposite. If you look at the couple by the virtue of W and normal, the couple by the virtue of W and normal, that would be equal to how much? W and normal are having a lever arm of how much? half of 1, that is 0.5. So I would have over here the couple, I don't have much space, so please try to understand what I am writing. Couple by the virtue of W and normal would be equal to 25 times 0.5, that would be equal to 12.5 kilonewton meter, right? And the same couple is supposed to be by the virtue of P and F, both of them will be same. So couple by the virtue of P and F would be equal to 12.5 kilonewton, that is equal to P multiplied to the lever arm or the moment arm between them is equal to 2 meter. So you can say the value of P would be equal to how much? 12.5 divided by 2, that is equal to 6.25 kilonewton. Now till now we have not got any of these options, but now we can get options from here. When the value of P is equal to 6.5 kilonewton, that is sufficient to impend toppling about point A. So I don't need to go till 7.5 so as to have motion. At 6.5 itself I am having motion, that to which motion? Overturning motion is taking place. Now that we know this information, let us answer the questions. Okay. In these cases you have to go for elimination technique also. Let us look at the option 1. The motion of the body will occur by sliding only. Perfectly wrong answer. Okay, because I am having toppling taking place before sliding, so sliding only is wrong. No motion would occur for P less than or equal to 6 kilonewton, that is fine, because for me to have any kind of motion I need 6.25 kilonewton. So 6 or less than 6 is no motion, so this is correct option. The motion of the body will occur by overturning, that is correct. If the body is experiencing overturning first, I would not expect it to have translation taking place. I would expect it to have overturning about A itself. So sliding of this body will not take place. The moment I start applying P, I keep on increasing the value of P, first overturning would take place, sliding would not take place over here. So option D also would be correct over here. So answer is supposed to be B, C and D. These three options are correct over here. So this was the only question from mechanics to have appeared. Last year we have had questions from vibrations in both the papers. Incidentally, I have not found any question from vibrations in forenoon paper as of yet. Probably there was a question which we were not informed about. So these were the topics of fluid mechanics and engineering mechanics. Thank you.
Irrigation subject, as like every year, it is very simple questions have been given. Of course, as per the information we received, there may be some data missing. We will see the correct answer, exact answer only after we receive the question paper. If you look at the question, if consumptive use of crop is 2.8 millimeters per day with the overall depth of 80 millimeters of soil, the depth of the soil in which crop is irrigated 80 mm is not a right one, it may be 80 centimeter, but from the students memory based question we got 80 mm, consumption of irrigation is 50%, find the frequency of irrigation. With the available data we know the formula for frequency of irrigation dW by Cu, 50% of 80 mm, 50% of 80 millimeters divided by consumptive use every day, on the average it needs 2.8 millimeters. If we simplify 40 upon 2.8, you will get around 14.03 days. So very nearly we will be taking 14 days is the answer. It is given for 1 mark, straight away formula based question. Let us see the next question given for 2 marks. In the contact of a cross drainage structure, the correct statements regarding the relative position of a natural drain and irrigation canal are, the question is given. In a canal siphon, natural drain water goes through the irrigation canal, In a canal siphon, we have drain water will be running at a higher elevation and canal water is going on the ground. So, the drain water going through the canal, irrigation canal is not correct. So, this is the wrong answer. In an aqueduct, natural drain water goes under the irrigation canal. In an aqueduct, natural drain water goes under the irrigation canal is correct, first part. Whereas in a super passage, natural drain water goes over the irrigation canal, that is also correct. So, the second statement is totally correct. The third one is exactly counterpart of the B. In an aqueduct, natural drain water goes over the irrigation canal. It is not correct because canal water goes above the drain. Whereas in super passage, natural drain water goes under the irrigation canal, that is also not correct. So, option C is correct, not correct. In a level crossing, natural drain water goes through the irrigation canal. Even though both are running at the same elevation, the two waters will not get mixed up. Only in inlet and outlet they will get mixed up. So, level crossing also cannot be the right option. Only one answer is correct, even though given as MSQ. Only one option is correct, that is B option is correct answer. These two questions are given for 3 marks in the subject of irrigation engineering. Let us see the question given in open channel flow. For a slope, it is given in GV of flow profiles. For a slope to be steeper to the steep, from the greater angle made with horizontal, the slope will be, it will be making lesser angle with horizontal. So, it must be on the steeper side, it must be S2 profile. Second possibility, on the steeper bed S2 profile with steep side S3 profile, or otherwise on the steep side S3 profile. Any one of the 3 options must be possible as we know. But as you can see, from the steeper to the steep slope, whenever you are having the flow, the free surface line is rising. It must be a rising curve. As you know pretty well, always S2 profile is a falling one. Only one option is available, first 2 are not correct. The only one correct option is possible, correct option is S3 profile. So, only C is the right option, correct option is C. S3 profile is the nature of the flow profile. Friends, it is given for 2 marks in open channel flow. Given for 2 marks in open channel flow, slightly lengthy numerical, and it can be done in 1.5 minutes to 2 minutes. See the problem given. Section 1.1, bed width is given as 3 meters, depth is given as 5 meters, discharge is 12 cubic. What is the maximum width contraction provided? Maximum width contraction provided in order to have the downstream critical. So, at the downstream section, flow must be critical. Has asked not the bed width at the contracted position, maximum width contraction provided. If here I got B1, say let us say B1, here B2 has asked what is B1 minus B2. So, the question asked is, many people may get confused at this point. See the wording, the maximum width contraction provided in order to have downstream critical. So, here the flow is critical. So, here once I calculate YC, from YC I can calculate Q2, the unit discharge at the second section. Once I get unit discharge at the second section, B2 can be calculated. Between section 1 and section 2, what is the maximum contraction in the width that has been provided, we can calculate. Only this is lengthy numerical. Calculate the energy at the first section, my dear friends. At the first section, E1 is equal to Y1 plus Q square by 2G Y1 square. Y1 depth is 5 meters. Unit discharge at the first section, I am writing here Q1, friends. Discharge is 12, bed width is 3, 12 by 3 that is 4, 4 square is 16. 2 into, for mathematical convenience I am taking 10, Y1 square is 25. So this is 8, 5 plus 8 divided by 250, you can multiply with 4, 32 divided by 1000. Very comfortably you get the total energy at the first section will be, the total energy of the first section will be 5.032 meters here. Without disturbing on the upstream side, critical section has to be formed on the downstream section with the maximum bed width of contraction. That is why my E1 is equal to E2, but it must be critical section. For a rectangular channel, critical depth YC is given by E minimum, that is 3 by 2 YC. E1 is 5.032, 3 by 2 times YC. YC is equal 10.064 by 3. You will get around 3.35. You are able to calculate the critical depth of the flow. Let us calculate what is Q2, unit discharge at the second section, my dear friend. Q square by G whole power 1 by 3 is YC. So Q2 is equal to square root of GYC cube. If we simplify this, G value is 10, YC is 3.35 whole cube. You will get Q2, from that you will get B2. B2 is equal to, you can get simply Q divided by Q2. Q is 12. This value is around, let me see the value. Q2 will be 19.43. So this is around 0.6 meters. For B2 is around 0.6 meters. From 3 meters it has reduced to 0.6 meters. Has asked what is the maximum contraction in the width, that is nothing but B1 minus B2 from 3.62, I think 0.62 is nikal diya. 2.38 meters is the expected answer. It is given in NEAT question for 2 marks in open channel flow. What is the concept involved in this? Bed width 3 meters is reduced to such a width such that a flow is changed to a critical minimum specific energy condition. For that purpose, how much is the maximum contraction the bed width is needed? So calculate even here, equate to that specific energy at that section, from that get YC. YC is known, then calculate Q2. Once you know Q2, capital Q divided by Q2 will give the bed width at the second section. I know B1, I know B2. What is the contraction that has been made? B1 minus B2 is the answer. इसके लिए 2 मिनट से 3 मिनट तक लगाने के chances हैं. Only the only problem which takes more than 2 minutes. And these two are the problems given for 3 marks, irrigation 3 marks and open channel flow 3 marks. The standards, the other 3 questions are very easy. This is slightly tough. Thank you.
So let us look at the first problem here. So the bearing of a survey line is north 31 degrees 17 minutes west, that is given in reduced bearings, right? Its azimuth observed from north is dash. Okay. Now, some students are giving us that they are asking azimuth. Some students are saying they are asking for WCB. Okay. So here reduced bearings are given. They are asking you for the azimuth. Okay. So what we need to do here? Right. If you try and represent the given data here, if this is our line here, now they are giving the reduced bearing as north 31 degrees, 17 minutes west. Okay. So this is how the reduced bearing will look like. So this is 31 degrees and 17 minutes. Okay. So here what we need to do is we need to represent the full circle bearing line. Okay. So just to convert reduced bearing to full circle bearing. Okay. So how do we convert that? What is the angle that we are looking at? This is the angle that we are looking at. Okay. That is the angle that we are looking at. So here azimuth or azimuthal bearing that is measured from the north end clockwise direction. It goes like this. The WCB will be equal to, like our azimuth will be equal to here in this case 360 degrees minus of 31 degrees and 70 degrees. Okay, right. So roughly you should get the answer. 360 minus 30 is 330. 330 minus 1 degree is 329. So roughly you get it as 328 degrees. Like 17 minutes is there. So that is 3 minutes. It becomes 20. So 45 minutes. Okay. Now you have to report this answer in your NAT model. In NAT model, by using virtual calculator, you cannot enter like this. So let us convert that into, let us say, decimal points. So then the answer becomes here as 328 plus 43 divided by 60. Okay, that will be the answer. So we are converting the minute into degrees. So then I think you will report the answer as 328.7. So that should be the answer that you will be looking like. Okay, right. So that is that. Next up, a line PQ, right? A line between P and Q laid on a slope of 1 in 5 was measured to be 350 meter using a 50 meter tape. The tape is short by 0.1 meter. The corrected horizontal length is dash. Okay, so this is the same question that we have tried in our ACE Premier League. Okay, so let us try and represent the condition here. So you are basically having a sloping ground like this. Okay, you are basically having a sloping ground like this, and the slope angle is given to me as how much? 1 in 5. Okay, now the sloping distance, the entire thing is measured to be equal to how much? 350 meter. So this will come as 350 meter. But the problem here is the tape was too short by 0.1 meter. Okay, so this 350 meter itself is wrong to begin with. This 350 meter itself is wrong to begin with. So what we'll do, first of all, we'll correct that. Find that what will be the correct sloping distance. After that, you apply correction for slope. Okay, so basically there are two corrections coming here. Correction for the incorrect chain length followed by correction for slope. Okay, we'll find out what this angle theta is later. Okay, so first of all, let us correct for the length here. Okay, so the designated tape length is given to me as 50. Okay, and in reality the actual tape length is 0.1 meter too short. So 50 minus 0.1, it should come as 49.9 meter. Okay, now the measured length is L dash. We'll represent it as small l dash. We are getting it as 350 meter. Then what will be the correct length? It will be equal to L dash into capital L dash by L. So it will be equal to 49.9 divided by 50. Okay, and this value will come out to be as how much? 349.3 meter. You will get it as 349.3 meters. Okay, once that is done, we can apply slope correction here. So what will be the value of theta? Theta will be equal to tan inverse of 1 in 5. Okay, that will come out to us how much? Something close to 11.31 degrees. 11.31 degrees. Now you apply the slope correction. So correction for slope will be equal to, see, we are having calc C, so we will go with the actual equation. Okay, we will not take the approximate relation as L square divided by 2n. Let us not go for that. We will go for the actual relation. It is L into 1 minus cos theta, the sign is always negative. Okay, L into 1 minus cos theta, the sign is always negative. But here we will use the correct length of 349.3 meters. Okay, so it will turn out to be 349.3 into 1 minus cos 11.31 degree, the sign is always negative. We will get the answer as minus 6.728. Minus 782 meters. Okay, that's it. Now what is the correct length? What do you do with the correction? You add it to the measured value. So take that measured value here. So in this case it becomes 349.3. So 349.3 plus correction. So plus with the minus sign, it becomes 6.782. The answer will look something like 342.5179. Okay, 342.5179. Yeah, that's it. Okay, so that is the answer. Okay, so similar model we have already discussed. Okay, right. So that was the second question from surveying. Now let us look at the third question here. So as discussed, photogrammetry is important. We have seen that. An aerial photograph is taken from a height of 3.5 kilometers from a camera of focal length of 152 millimeters. The average height above the mean sea level is 460 meters. That's the ground elevation. Find the scale of the photograph. So we need to find the scale here. Now we know the scale formula. Scale is equal to focal length divided by flying height minus. In this case, they have mentioned average height, so we'll write it as h average. Okay. Now what are the parameters here? 152 becomes the focal length, 3.5 kilometer will become the flying height, and 460 becomes your average ground elevation. Remember, it is a ratio, so they have to be in the same unit. So bringing them into the same unit, 152 meter will become 0.152 meters, 3.5 kilometers becomes 3,500 meters minus ground elevation is 460 meters. Okay, so this will be in meter. Meter will cancel, and this will come out to be exactly 1 in 20,000. This will come exactly as 1 in 20,000. That's it. Okay, a very straightforward problem. Okay, so there was the 3 questions for a total weightage of around 4 marks. Correct. So that was surveying. Now let us look at that APL question. So this was the question that we have done in our YouTube live session. Okay, that's it. You can go and check it. So here I asked for correction, but there they have asked for the corrected length. That's the only difference. Let us move on to the next subject, that is transportation engineering. So here you can see the vehicle count obtained for every 10 minutes interval. Traffic volume survey done in peak 1 hour is given below. So this is from traffic. Okay. So the interval of total observation is 0 to 60, that is 1 hour. And how many vehicle counts are there? You see 1, 2, 3, 4, 5, 6. Okay. So they are having 6 counts here. Okay. What are they asking us to find out? What is the PHF? Okay. Peak hour factor for 10 minutes. Now as per IRC, what is the peak hour factor? As per IRC, the peak hour factor goes as the total flow observed divided by 4 into Q50. Okay. That is what IRC suggests. But here they have changed that 15 minutes interval to how much? 6 minutes interval. So in this case, what will be the peak hour factor? It will be equal to total flow divided by 1, 2, 3, 4, 5, 6. 6 into the highest value in the 10-minute interval observation. Okay. So let us take the total Q value. So 10 plus 11 plus 12 plus 15 plus 13. So 10 plus 11 plus 12 plus 15 plus 13 plus 11 divided by 6 into, what is the maximum value? What is the peak value? That is 15. So 6 into 15 you will do. So this will turn out to be how much? Right, this will turn out to be, yeah, I think 0.8, right? Yeah, this, very good. So it will turn out to be how much? 0.8. That's it. That's the peak hour factor. Right. So next we will see this question here. This is again from traffic only. Consider the 4 points PQRS as shown in figure. So one data is missing here, that is the graph here. So what I'll do is I'll just try and represent that graph here. So that is speed versus flow graph they have given. Okay, right. So this is our speed, right, and we have our flow here. Okay. Right, now how does the curve looks like? They are saying that the curve is looking like this. They have identified 4 points here. They are P, okay, followed by Q here, followed by R somewhere around here, and this is the S value. Okay, so this is the data given. Okay, please try and understand that. Now let us read the question shown in the figure. In the green shield fundamental speed flow diagram. Okay, denote their corresponding traffic densities. So we need to find out the traffic density as Kp, Kq, Kr, Ks respectively. The correct order of the densities is, okay, so what is the correct order of density? So we are using green shields fundamental model. So that is linear speed density model. So how does it look like? So linear speed versus density model. So directly we are getting it, and since it is a linear speed density model, we should get a relation that looks something in this particular fashion. Okay, so now let us try and project this particular data into our green shield model. So we'll do this. This is projected here. Okay, R is projected here. Next Q is projected here, and P becomes projected, and it comes up to here. Okay, so these are the points that we are going to get corresponding to the points of S, R, Q, and P. So S, R, yeah, that is Q, and that is P. Okay, now what are we trying to find out? We are trying to find out the densities. So let us just project them down here. Okay, so whatever density that we get at this point will be corresponding to the point P. This will be the density corresponding to the point Q. This will be the density corresponding to the point R, and this will be the density corresponding to the point S. Right. So now tell me, who is the greatest among them? You can see now. So it is increasing in that direction. Kp more, followed by Kq, Kr, Ks. So Kp greater than Kq, greater than Kr, greater than Ks. So Kp is greater, Kq followed by Kr, Ks. Okay. So Kp is greater, Ks is the least. Kp should be the greatest. Yes, Kp is the greatest, right? And Ks is the least. So we should go with this particular option here, right? That is option B. Okay, Kp greater than Kq, K greater than Kr, greater than Ks. That's it. Okay, so that is green shield's linear speed density model that we have. Okay, now let us look at this particular question. So the design speed of highway is 100 km per hour. Calculate the stopping side distance assuming reaction time of drivers as 2.5 seconds and the coefficient of friction is given to you as 0.26. Okay, when highway is on level ground. Okay, so level ground, no gradient is there. They have not mentioned anything regarding the brake efficiency also. Okay, so what is the formula here? Stopping site distance will be equal to, since we are using calci, I will go with small v only. Okay, small v into t, right, plus v square divided by 2gf. Okay, so here first of all we need to find out the velocity in meter per second. Capital V is given to me as 100 kmph. Okay, so when we convert that into small v, you just need to multiply that with 5 by 18. You will get the value as something close to 27.78. Okay, 27.78 meter per second. Okay, now substitute the values here. 27.78 into reaction time is 2.5 seconds plus 27.78 the whole square divided by 2 into 9.81 into frictional coefficient is given to me as 0.26. Direct formula based question, you get the answer as 220.59. 0.59, the answer is in meter. Okay, that's a direct question. Okay, so this is from geometric design. Okay, now let us look at the next problem here. So this is again from our traffic only. A two-phase signalized intersection is designed with a cycle of 100 seconds. So that is a total cycle time. Okay, the amber and red time for each phase are 4 and 50 respectively. Okay, yeah. Now respective, if clearance loss time is 2 seconds, then the effective green time is dash. Okay, now please tell me, what is this total cycle time? Okay, total cycle time is what? It is nothing but we have three signs, no, red, green and amber. So the sum of all the three is nothing but your total green time. Okay, so this will be written like something like this, right? Display green, okay, plus amber, okay, plus red. Okay, now, right, like this we'll take. So total cycle time is given to me as 100. Okay, display green we need to find out from this, because once we find out display green, we can find out the effective green time. So display green, okay, plus amber time is given to me as how much? 4 plus 50. Okay, so 100. So 50 minus 4, you will get display green as 46 seconds. Okay, right, that's it. Now what is the effective time? So effective time means, even though we are having this much amount of display green, this much amount of amber time, in reality what happens? Suddenly if the signal change, there is going to be some losses. Okay, we have two losses, startup losses and clearance losses. Okay, so the loss that is coming due to startup is not given, right? The loss that is coming due to clearance is given. So only clearance loss time is taken. Okay, so what do? You ignore your startup loss time, or you take the total loss time as 2 seconds. That's it. Just ignore the startup loss time. So what will be the total display green that we get? The total display green that we will get will be equal to, right, sorry, we are trying to find out effective green, no, here. So right, so will be equal to, right, display green, okay, display green plus amber, because amber plus display green is coming as the total green time minus the losses. Okay, there are two losses, but only one of them is mentioned, so we'll talk only about that. So the total display green is 46 seconds plus the amber time is anyway given to me as 4 seconds minus the loss is given to me as 2. So 46 plus 4 is 50 minus 2 is what? 48. You get the answer as 48 seconds. Okay, so that was another question from our traffic. Okay, now let us look at this. So this is from design. Okay, so design of flexible pavement. So for a dual wheel carrying assembly, P is the load which, okay, there is small confusion here. P is the wheel load. Let us take P as the wheel load. Okay, A is the radius of contact area. So A is the contact area radius that is given. S is the center to center spacing between the wheels, and small d is the clearance between the two wheels. Okay, assuming that the ground is an elastic homogeneous and isotropic half space, right, that means one side infinity, the other side is restricted. The ratio of ESWL, equivalent single wheel load at depth equal to d by 2, right, comma, the ESWL at depth is equal to 2s, that is given, that is what they are asking. So we need to find out the ratio of two things. Okay, so we need to find out ESWL, the equivalent single wheel load at d by 2, okay, and ESWL at which point? At the 2s. Okay, what will be this ratios? I think you can directly say it, but for the sake of discussion, I'll just try and represent it. So if this is what our ground looks like, let us take the standard dual wheel assembly that we have. Okay, right. So the axle will go something in that particular fashion here. Okay. Now, what is small d? This is capital S, spacing, center to center spacing. Okay. What is small d? Spacing between the two wheels. Okay, that is small d. Okay. Now they have mentioned in the question that we are having 45-degree distribution. So we'll assume that it goes something like this. Yeah, it goes something like this. So where these two intersect? Where do these two intersect? At a depth of d by 2. Right. So only effect of one load will come. So here the load will be P. Okay. Equivalent single wheel load will be P. Right. Next we need to consider at a depth of 2s. Okay. So this is the depth of 2s where the effect of both of them will come into picture. Effect of both of them will come into picture. That will be nothing but 2P. Okay. So what is the equivalent single wheel load at d by 2? That is P. At 2s it is 2P. So coming back to our original discussion. So here we are going to get P. Here we are going to get 2P. So the ratio is nothing but 1 by 2. Numerical answer type question. So you report it as 0.5. That's it. Okay. So these are the different questions that we had from our transportation engineering. That's it. Okay.
Yeah, I will add a few more questions of the other subjects there. Let us take the CPM. Here you are given some data of the activities there. You are asked to find the critical path as well as the total duration. Because you have few activities only, I think this can be solved very, very easily. You can see P and Q activities, they are not dependent on any other activity. So they are the starting activities. You can draw the network like this. So this is activity P and activity Q. The two are the starting activities. And R and S, R depends on the P. And S depends on Q. So you are given the dependency there. Then we have mainly with respect to the last act, that is nothing but a T. The T depends on P and Q. T depends on P and Q. You have the P and Q here. So therefore you have to introduce here some dummy activities. So I will introduce like this. So we have to introduce two dummy activities. Then you have to start this activity T. Now let me check it. The T depends on P and Q. Hope it is satisfied. So that's all. So here we so this is what the simple network there. You are given some active timings there. The P timing is 10 and the Q is 12 R is 5 and S is 10 and T is 10. You are asked to critical path as well as total duration. You do not have to go for the what you call detailed analysis there, just by glance you can pick up the what you call critical path as well as the duration of this one. You can see here I think we had some, right, sorry. R depends on Q. R depends on the P, S depends upon the Q, T depends on P and Q. Yeah, now here you have to introduce that last final event. So now let me check this longest path here. You can see 10 plus 5, it is 15, the durations, and this is dummy activity. So 10 plus 10, this is 20, and if you take this path 12 plus 0 plus 10, this comes to be 22, and if you take this path Q and S 12 plus 10, that comes to be 22. So among them the longest one is 22. So therefore the duration of project is 22, but you can see there are two options there. You have to find the critical path also. The 22 comes for the QT as well as QS. So therefore you can see QS is there and longest duration is 22. So this is the answer. A simple question only. Next is one question from the steel structure subject. You are given here one angle section, as you can see here. This is having some welding here. Here you have the welding. You are asked to find the length of the two welds, that is L1 as well as L2. And if you read the question, what you can see here, area of the angle is given, allowable stress is also given there. Because you know area as well as allowable stress, this is a welded section. From that you can find what you call the load carrying capacity of this angle, load carrying capacity of this particular angle. Then we have two unknowns here, L1 and L2. To find two unknowns, we have to develop two equations. Because weld size is given, that is 5 mm, allowable stress in the weld also given there. Allowable stress in the weld is, this is 108, 150 is the allowable stress in the angle. So allowable stress in the weld is given, the weld size also given. From that you can find the weld strength per unit length. Here, per unit length, if you know the weld strength, you can find the total force that is carried by this length L1 as well as this length L2. Let us say this is P1 and this is P2. So you can find the P1, P2 in terms of L1, L2. So you can have to equate P1 and P2 to the strength of the angle. That gives you one equation. And then to develop another equation, take moments of P1 and P2 about any point here. That gives another equation. So two equations to unknowns, when you solve it, you can get what you call L1 and L2. That gives you finally the answer as the B. Just to save some time, I have not gone to the detailed solutions here, just I have given the outline only. That's what about this. Still only one question was there, right? Still we have some more questions that you could not provide you because of time constraints and other reasons. I think you can see in the couple of days, IIT also going to upload the papers. We are going to give the detailed solutions, right, in much more details there about other subjects, other questions as well. Yeah, thank you. So far we had some analysis of the paper 1. So as you have seen there, most of the questions are rather easy. But we have got a feedback from the students regarding the afternoon session paper also. But this is something quite different from compared to the morning session paper. Earlier we have commented that paper 1 morning session was somewhat easy. But when you see the paper 2, the type of questions what you are receiving from the students, what you call memory based questions, and as well as the comments of students. So many students are what they are commenting on the paper 2 is it is not an easy paper. So most of the students they are saying that what you call moderate, otherwise somewhat tough, right? So we can say totally it is not an easy paper, it may be moderate to tough only. So therefore paper 1 somewhat easy and paper 2 is not easy, moderate to tough. So therefore the normalization is going to make some impact on this paper 2 as well as paper 1 totally. So based on normalization, we can come to know the what will be the actual cutoff and what you call the all India first ranker marks, etc. But more or less, the number of aspirants are more there. You can see last 3 years cutoff, last 3 years All India first ranks, it may be somewhere nearby this one. So let us seek the, because my colleague faculty members also are observing the paper 2 questions. Let us take their feedback also regarding the level of the questions as well as the standard of those questions of the paper 2. Let us see these comments of our colleague faculty members. So Pradeep, what do you say about this paper 2?
Sir, yes, sir. So the feedback has said that for surveying, more number of questions have come. That's what I've understood. So slightly bigger weightage is coming there, and also in general, the comment is not similar to what we got in paper 1. So slightly moderate to difficult paper is what we are expecting. Okay, some maybe you can expect some untapped questions in that. Students might have seen that some untapped questions. That's why this kind of response is coming from them. So nothing to worry, normalization will take care of this. So don't think that forenoon people are very lucky, they are going to get good ranks. Nothing will happen like that. IT will take care of that, the gate committee will take care of that, and normalization will play a very critical role. So we'll see how the paper goes in the next session, and we'll have a better idea about how the paper is.
Yeah, comment, Keshwar Reddy.
Coming to the afternoon session, most of the students are saying that it is moderate to tough. Especially if I see the strength of material questions, one question with temperature and external force. That is slightly trickish. If you solve it, it is easier and not that much critical to simplify the things, but slightly tricky. And one lengthy question from the pre-stress concrete came. That was a previous engineering services question asked for 20 marks. Now it is a 2 marks question, a lengthy question. So that may be a bouncer to the people. And coming to the other questions, those are all moderate to tough. So as Pradeep is saying and AK sir is saying, the normalization plays a critical role there. Definitely no need to worry about the people who are writing the paper in the afternoon, who have written the paper in the afternoon. Definitely there will be added marks to the afternoon session, and normalization will be by adding the marks and all, as you know. So no need to worry about it. You get the balanced ranking system. Okay, worry.
As far as mechanics is concerned, I have received 2 questions, one from friction as expected and one from vibration. I do not know whether vibration question was present in the paper 1 or not, but for paper 2 we had a very simple vibration question, extremely simple question. Just by changing the amount of mass, what would happen or what impact would it create on time period, that kind of question has appeared. Both the questions were relatively easy only in mechanics. In fluid mechanics, I understand the questions were not as simple in afternoon session as they were in the forenoon session. But then again, I hope you could tackle them well, because they were based on the fundamental concepts only. They were not as simple though, but don't worry, don't be disheartened by difficulty level of different papers. You see, when such a big committee is taking care of this big examination, they will have some way of justifying it also. Okay? So don't be disheartened at all. Let us hope for the best. Okay? Sir, please.
Yes, don't worry friends, evening students, don't get depressed. Definitely there will be modernization, normalization factor, and there will be balanced ranking. Questions are a little bit moderately tough. Don't worry about that. Okay.
Yeah, I once again re-emphasize this point that one session may be tough, one session may be easy, but remember, there will not be any undue advantage for the morning session papers because it was easy. At the same time, there won't be any undue disadvantage for the afternoon session because it was somewhat moderate to tough. Normalization will solve all the problems. Whether you appeared a morning session paper or evening session, afternoon session paper, doesn't make any difference at all. Right? Doesn't make any difference. Just be cool, wait for the actual result there. And we wish all the students very good luck. And because of time constraints, etc., we could not make the analysis of the the detailed analysis of the afternoon session paper. We will come with a separate video if possible, the each subject wise detailed solutions. For now, we have made a qualitative remark on the paper 2. So with this, we would like to conclude this analysis and wish you all good luck in all your future endeavors.
Good luck. Thank you.
Thank you.
Thank you.